Okay. Let's see. Connect. Yeah, I know you're all done with it. Give me a minute. I got to do attendance still. Okay, so let's see. Alex is here. Mason's not here. Evan's here. Yeah, happy. Okay. 2, 3, 5, minus Forest. 11, 20. Oh, Cooper. Done. There. All right. Hopefully you're wrapping things up with your quiz. So if you are done, feel free to turn over your paper and send it towards the middle so I can see that you're done. You just need to fill in that last number at the end there. That's fine. Hey, you can do it. It's a quickie. Everyone's almost done. You can do it. You're all set. Excellent. Excellent. All right, very nice. Good job. All right, I'll just polish off mine up here, and then I'll come get yours. Okay. All right. I've got both. There. Okay, I did mine in short order. So hopefully you did yours in by now. You get what you have. Here, same things. Thanksgiving themed and Christmas themed. All right, you have at least some numbers. You don't have to write, you can just write down the formula instead of the numbers. Yeah, because we gotta get going here. Sorry, I'm making you nervous, aren't I? That's okay. Let's see how these people did. All right, here, I'll at least you got the first one. That's good. Okay, so let's go ahead and see how this shook out. I think I've got them all. Make sure that is anyone holding out on me? No, okay. There we go. All right, so let's take a look at what I have. Hopefully I got it right. Unfreeze. Wait, is the recording going? I think it is. Yes, it is. Okay, so the first one. You had two options here, but most of you chose hopefully the easy option, and that is that the sample mean was listed right in the Excel output. Now, I should warn you that when it comes time for the test, I probably won't give you this little block here, so you'll have to compute it yourself. So if you did go to the trouble of adding these numbers up and dividing by however many there were, 8, then you would get the same thing, but it's right there. So in this case, it was simple, right there, boom. In terms of the margin of error, it's just that central, so this plus or minus, or sorry, the confidence interval, plus or minus the margin of error, 4, 5, I think we could just stop at 9 there probably, since we only have 3 digits after a decimal place here. And in fact, when I got down to my complete sentence, I thought it's kind of silly to talk about 2.916 pillows, and so I just rounded to the nearest tenth, and that's fine. I wouldn't, yeah, if you rounded to the nearest integer, that's, I don't know, that might be appropriate in this situation, but it's okay to have a decimal number of pillows, like 2.9 pillows, fine. Because we're talking about an average. Averages can be decimals, it's fine. So anyway, then I've got my sentence. I am this confident that the true mean number of pillows. So what are we measuring? We're measuring the number of pillows in MVNU dorm rooms. So it's the true mean number of pillows in MVNU dorm rooms is between, and then I just put my 2 numbers that I got from my thing up here. So, so that's the sort of thing you can expect on the exam. When is it? Next week or 2 weeks? I hope it's not next week. 2 weeks? I don't know. I'll figure it out. It's on my count here. I'll find it later. I don't think it's next week, but it might be. Yeah, we have so few weeks between now and the end of the semester. But it's on. I said at one point, so whatever I said, I'll stick with that. Okay. So did I get it right? Yeah, I think I got it right. Any questions? Pretty straightforward. Yeah, I didn't. You can expect on the exam something similar for the proportions. On your homework, you had both proportions and means, where you had to use that confidence interval gold web, or Excel spreadsheet. And so hopefully you can do that here. You're going to be using this when you do a project for me in the next week or so. But first we need to talk about I guess project 1 is the first thing that I have on my list. So let's talk about project 1. What is this project? Well, back at the beginning, I gave you a syllabus, and I have so much optimism when I start the semester. I don't know if you're this way too. You think, oh, it's going to be, we're going to have all this fun and all these new things. And I had this envisioned, all of these projects. I think it's my vision has been shrunken. In the past, just to let you know, in the past I've had as many as 6 projects per semester in this class. This semester, though, it might be only 3. So my apologies for you for that. We should have done at least 1 project before fall break, but we didn't. So this will be project 1. So project one, it's not that hard of a project. Let me show you what it is. It's already on Moodle, so I'll explain it to you really briefly here, and then we'll move on to the new material. You should be able to do this pretty easily now because we've already done everything you need. So you'll find the projects, the list of projects down here under projects. So you see project one, I've got project two, but it's not available to you yet because I need to do a few more things to it before I make it available. Project one though, when is it due? It's due Friday, November 8th. Yeah, that may be a problem. Let me look. I need to know when this next exam is. So let me pull up the syllabus. By the way, while I'm talking about this, I had someone email me this morning and say, hey, I'd like to meet with you tomorrow. Is that okay? Of course it's okay. You can meet with me anytime you want as long as I'm available. And here's how you do it. Go get the syllabus and scan this or click on the link. Here it is, there or there, either one. You can make an appointment with me. You know, if I'm available, I'd love to meet with you. So I let that person know that they could just click the link and schedule it for whenever I'm available. But anyway, let's go down and see when is the test. Because I don't want it to be the same. I don't want to have the test at the same time as the project. So I'll move the project if need be. Aren't there tests here somewhere? I thought I had the tests listed. Huh? I keep passing it? If only I would slow down, right? Oh, there it is, 11:15. I'm okay. I'm okay. 11:15, that's 2 weeks from this Friday. So I'm good. I'm good. So we're in good shape. 2 weeks from Friday is our next exam. So next Friday is our first project. Where is our first project? What is our first project? Here is our first project. So you will find project one listed on our Moodle page. When you click that, you will find this little description. Let me make it big so that we can all enjoy reading the text. Since I went to so much trouble to write this. So you're going to construct a 95% confidence interval for the number of births for the gender, day of week, and moon phase that you were assigned. So I don't know if you remember, I mentioned this, that my mother-in-law thought that more babies were born during full moons than during regular whatever other moon. And she said, but I worked in a neonatal unit. And so I remember it was always busy. It's like, oh, you know, we can actually check. So I downloaded the data and we actually checked, and it turns out, well, I guess I just gave it away. It isn't the case that more babies are born during full moons. But, you know, I thought, you know, this is a good, you know, easy first project. Is each of you will be given a gender, day of the week, and moon phase. You might say, how do I know what my gender, day of the week, and moon phase is? Well, I'm glad you asked. There is a spreadsheet. So I've got two spreadsheets here. One of them is the data you're using, and the other one is your assignment. So once I get this so that I don't have to continually use my trackpad because my trackpad is terrible. So here you'll find two spreadsheets. Down here, the project one data assignment is your assigned. So here, I'll just click on this. You'll see, oh, it's okay. It's showing up on this screen. I'll move it over. You will find a list of assignment. So you don't have to write this down because it's here. You can download it, and you're going to have to download anyway. So each one of you has, let's see, can I make this, let's see, view, freeze panes, freeze. Okay, does that freeze that? It just froze the top one. Here, let me just delete this. See, will that freeze? Okay, that's better. Okay, so you have your name, you can find your person, and then you have these three things that is your assignment. So let me go down to me. So I was assigned, what is it? Full, new, or neither? What does it mean? Just a minute. I forget what, I think it says here somewhere. Does it say? It doesn't say. Oh, drat, full, moon, or neither. Oh no. Okay, well, we'll find out what it means in just a sec because we're going to look at this YouTube playlist. It's the only way I'm going to know. So apparently, okay, so you notice that on this playlist, I have step by step, each step that you're going to go through to do this project. And with this first step, Let's just mute that. We don't need to listen to me. I'm blabbing away. I'm in my office having a good time, going down here, going to project, whatever. Let's see. I need to know what, because it's strange that it doesn't say. Well, I must say somewhere here. Okay. Oh, I see. So 1. Oh, it's the number. Okay, it's the number, whatever the number is on the, okay, I get it. Yeah, you'd think I would know. It's been a while since I made those videos, so that's why. So anyway, you go to baby data, and on baby data, click that, bring that up. That has the actual data, and I believe, okay, I believe that 0 under full new, there it is. Here's the actual data. I believe that 0 means just nothing, not a full moon or a new moon. I'm pretty sure that 1 is a full moon and 2 is a new moon. So if you're given 1, it means you're interested in full moons, 0, neither, and 2 is new moons. But if you watch the videos, you'll see how to deal with sorting the data. It's not that hard. And these are all the days between 1969 and I think 1989 or so. So you have all of this data that was gathered from the CDC and has, who was born when and so forth. So for example, I was assigned, where's my assignment? Here we go. I am full moon, so number 1, so 1 under full moon, new moon. 7 for the day of the week, which is, I believe, the Saturday is 7. And then B for boys. So I'm interested in boys who are born on Saturday during a full moon. And so anyway, you can find your assignment and you can do this. Once you're done, you should have a spreadsheet that looks similar to what I have in my video. So at the very least, when you're trying to decide, should I bother watching the videos? Well, some of you might say, I can just do this. It's easy. I can make a confidence interval. It's easy. But what you're going to want to do is at the end, you're going to want to have your spreadsheet. So this is my actual spreadsheet that I'm going to submit as my project. It should look something like this with all of my calculations here. And now I'm blabbing here about writing a sentence. And I'll have a sentence right here. And the sentence, let's see if I can finally get through. Yeah, there's the sentences, fill in the blanks, whatever. Do I ever do the sentence? Oh, there it is. Let me pause that. We can read the sentence. It's so beautiful, isn't it? Yeah, I'm 95% confident that the true mean number of boys born on Saturdays during a full moon is between this and this. So I guess you might say, well, we know what the true mean is because we have all that data, right? Well, we don't have the data for before 1969. We don't have the data for after 1989. So, well, we do have those data, but I don't have it here. So this is the true mean for all Saturdays and all full moons. So that's my confidence interval. Anyway, you're going to do something similar. You'll submit it online. You've got a week to do this. No more, a week and a half. So if you do have confusion or questions, you know what you can do? You can go to our either our Moodle page or go to our syllabus and either scan this or click this, make an appointment with me, bring your laptop. I'll help you. If the video isn't good enough for you, I will say, do that, and then do this, and then click those. We'll get it done together. Don't worry. It's going to be an easy one. Everyone gets 100 on the first project if they do it. If you don't do it, you can get a 0. I mean, that might be your choice. I don't know. But I wouldn't recommend it. I'd recommend doing the project because it's such an easy one. Okay, so there's project 1 out of the way. Now we're moving on. We've done confidence intervals. We're going to do hypothesis testing today. Just the basics. So the basics of hypothesis testing. And so a hypothesis test is where you have something that you think is true, but you don't know. For example, you might think that, you know how we had these 2 exam papers? Oh, I don't have any of them. So if you still don't have your exam from me from last time, sorry, I'll make sure that you get it someday. But so we had these 2 copies, 2 versions of the exam. I think they had either a plus symbol, like it was exam 2 plus with a circle around it, or exam 2 with a times symbol with a circle around it at the top. Whatever it was, you had 2 versions of the exam. You might say, I think exam 2 with the plus sign was harder than the times sign. And so that would be a hypothesis. a hypothesis that we could test using statistics. So hypotheses are all based on some sort of a claim, something that you're interested in testing. This is one of the things. Now, for the homework, we're going to take this slowly. So for the homework for Friday, you're going to be focused on 3 things. This first one, what is your claim? What are you interested in? Let me just show you an example of this. Going here, we'll come back to that slide momentarily. So suppose you want to test whether college students take less than 3 years to complete a 2-year degree. What are the null and, okay, we'll get to that in a minute. I want to just do the claim. So what is the claim? So, whoops, why does it always do that to me? Okay, so I just want to know, ignore the last sentence. So the last sentence, just ignore. Just take this stuff above this line here. And I want to know what the claim is. So the claim is that college students take less than 3 years to complete a 2-year degree. That sounds like a funny statement, doesn't it? But when we are evaluated by the federal government about our graduation rate, we generally say, what is our 5-year or our 7-year graduation rate? And we have a 4-year degree. So in other words, how many students or what percentage of students that start finish within, say, 7 years? Because some people take a little longer. My wife took 4.5 years to complete a 4-year degree. I kind of, if you count my CCP work, they didn't call it that back then I took 5 years because I just took my time. I mean, I came in with a year worth of work and then I did 4 years. I thought, why should I hurry things? My parents said, yes, you should hurry, but I didn't. But anyway, the claim. So what is the claim? So let's see, less than 3. If I write that in math, this would be something like this. I'll write it in math first, but I'll also write it in English. So less than 3, but what? What is less than 3? The thing that is less than 3 is finishing, so how long it takes college students to finish. But we're in statistics class here, and so we have to write this in terms of a parameter. So the parameter we're going to use, it's always going to either be mu or p. Those are your options. When you go to advanced statistics and social work or whatever it is, whatever class you take that is beyond this class, you'll learn about other hypothesis tests. But for us, it's always going to be averages or proportions. So this one, since I'm talking about the number of years it takes you to complete a 2-year degree, I go around and I say, how long did it take you? How long did it take you? And I would average those numbers together. So here, I'm interested in an average being less than 3. So I could write this like this, that the average number of years it takes someone, I know this is tedious, to complete a 2-year degree, sorry. 2-year degree is less than 3. So that's a claim. And it's a claim that I can symbolize like this, and you can see why I love math, is it takes me forever to write this sentence, but that sentence and this sentence are the same sentence. This one just is in symbols, and this one is in English. So anyway, there's what a claim is. That's going to be your first step to hypothesis testing. The second step to hypothesis testing is to write down the opposite of the claim. We're going to do this in symbols. So even if you have your claim in plain English, when you get to step 2, you need to write this in symbols. We'll practice this in a bit. For now, let's do this right here. So there's the claim. So I'll do it for you, but I'll have some for you to do. So what's the opposite? The opposite, so I'll even number these. This is step 1, step 2. Opposite is that mu is greater than or equal to 3. So notice that what is the opposite of being less than 3? Well, it is being greater than or equal to 3. So the opposite is always going to be completely the opposite. So if you have less than here, it's greater than or equal to. If this is greater than, this will be less than or equal to. If this is equal, this will be not equal, and vice versa. So that's, you have to, it's going to be, you're going to have to make sure that you know the opposites of your math symbols. Here, let's go ahead and list these because it's handy to have them on file here. So you have a symbol and its opposite. So this might be handy for you. So if you are equal, the opposite is not equal. Kind of makes sense. If your symbol is greater than, then your opposite is less than or equal to. It's the complete opposite. And then finally, if you are less than, then the opposite would be greater than or equal to. So here's the strategy I would have you do, just to make sure you get it right. I realize that some of you are like, I can do this. I don't need to think about it. I can do it quickly. But for the rest of you, what you should do is, first of all, take a look at this problem, figure out the claim, write it in symbols, and then once you've figured out your symbol, just rewrite that claim using the opposite symbol. And I know that seems super basic. You're like, well, we did this in 7th grade. Yes, you did. And it's been 6 or 7 years. So, I want to make sure that we're all in good place here. Okay, so let's go back to our list. All right, we're moving on. Number 3. Let's see. There we go. So what's number 3? The null and alternative hypotheses. Null and alternative hypotheses? What in the world are those? All right, well, we'll get to that in a sec. Do we want to do it now? I'm looking for, oh, it's way, way back there. Okay, sorry. There's something that we'll do that might help solidify this, but for now, here's the deal. The null hypothesis, so technically or mathematically, null hypothesis means no difference hypothesis. No difference means equals. So the null hypothesis will always have an equal sign. So null hypothesis has the equal sign. So the way we write this is H sub 1, is it 1 or A in this book? Sorry, let me just look at this. A, okay, they use H sub A. Sorry, I've got some screenshots from, so when you do the alternative hypothesis, make the subscript A. I'll have to correct that in the PowerPoint a bit, but it's H sub A for alternative, H sub 0, 0 meaning no difference. You have no difference between whatever it is you're looking at. For example, if we're interested in the 2 exam papers, maybe it's like, I don't think there's any difference between exam, the 2 exam versions. You might say, I do think there's a difference. And now we have a competition. Which of the hypotheses is correct? So the main thing is to make sure that the null hypothesis has the equal sign. So let's go back to our little example we've been working on here. Number 3 that we're doing. And I think that this is the last bit that we need to do for today. And then we have a bunch of examples. But the null hypothesis is the one with the equal sign. So greater than or equal to, and then the alternative is the other one. Sorry, sounds like some low frequency vibration. Is there something going on? Is it the speakers? Maybe it's just me. No. I mean, when I'm in the afternoons, the Ignite kids are back there behind that wall making food, and so there's oftentimes blenders or stuff. You can hear it. It's the walls paper thin. But, they usually aren't making breakfast. I don't know what this is. Well, anyway, okay. There is a bonus sort of thing, and that is, are your hypotheses left, right, or two-tailed? So let's just explain this, and then will we be ready to move on to the examples? I don't know. Let's see. Explain this, though. So left, right, or two-tailed. Well, here's how you tell. You look at the alternative hypothesis. So here's the alternative hypothesis, and you ask yourself, is that little arrow, does it point to the left, to the right, or is it both directions? Well, if you look at that symbol that I have there, that thing points to the left. This is called a left-tailed test. Another way of looking at this, I mean, this is really why we're interested in left, right, or two-tailed, is to think in terms of a normal curve. So here is what this is going to look like. You have your statistic. So you're going to gather statistics. You'll have your statistic here. You'll have a confidence interval. The confidence interval tells you that the truth, that is mu, is somewhere within that, hopefully, somewhere within that confidence interval. What this is saying is that the alternative hypothesis is that the mu is over here somewhere to the left. So that's what that's referring to. Left-tailed just means mu is less than whatever your average is or whatever it is. And so, so you'd have something like this over here. So that's left-tailed, and that's why we're interested in this, because the probability is going to be computed either one way or the other. So we're going to have to deal with that as well. This is going to require another spreadsheet that we're going to call Hypothesis Test Gold. That's for next week, though. So next week, we're going to have to do some work with Excel. Be ready. But we will do that when we get to it. Okay, I think that that's all that we really are going to do today. But let me show you the other steps, because we're going to be doing all of these, every single hypothesis test from here till December. We're going to do all 8 of these steps. So those 3 we're focusing on today. We're also going to determine alpha. This is usually given to you in the problem. You're going to determine which distribution you will use. Basically, this just refers to how am I going to do this using Excel spreadsheets and the functions. So it's always either going to be the t distribution or the z distribution, or when we get to some other distributions, we will use the f distribution, and we will sometimes use the chi-squared distribution. So this mainly refers to what test do you use on Excel. Then you compute the test statistic and the p-value. More on that later. On Friday, we'll deal with that. We'll make a decision, and then we will write our results in a complete sentence. Just like with my confidence interval, I have a template where you fill in the blanks so that your sentence communicates what you want to communicate. I mean, that's part of the point of this, is trying to communicate well using statistics. So that's why I have fill in the blank sentences. Just one quick note about hypotheses, and then we will move on to some examples, and that is this, that the null hypothesis is sometimes called the chance hypothesis. So the reason why it's called the chance hypothesis is because this is just maybe by chance you got something that looks unusual. By chance, students who had one of the test versions did better than the other test version. By chance, I just happened to give those exams out in the way that I did to the smarter students, and the ones that weren't as smart got the harder test, or not the harder. There's no difference. You can look, you can look at the actual exam papers. There's no difference between those 2 exams. But just by chance, it might be that one got one and the other. By the way, when we get to the hypothesis test where you compare 2 means, I'll bring the actual data from this class, and I'll put to rest any concerns that one of the exam versions is harder than the other. So chance hypothesis. This is what would be true if any difference between the statistics was just random chance, which it could be. By chance, you might pick whatever it is that you're studying, you might put them into groups in a way that makes it look like one group is better than the other or whatever. Okay, so the other one is the alternative hypothesis. Here I've got it correct with the H sub A. The alternative hypothesis is, this is sometimes called the research hypothesis, and this is usually what you're researching. So the alternative is usually the thing that you're really interested in. So the claim is usually going to be something that is an alternative, but not always. Okay, so we've already done this one. So let's, oh, we've got a second one though. I see. I have to erase all this. So I've got one for you to do. So let's just erase all of this, clear, and go to the next one. So suppose you want to test whether the mean salary of nurses is different than $45,000. I want to know the null and alternative hypotheses, and I will get them by doing the following 3 steps. 1, 2, 3, and then the bonus step of is this left-tailed, right-tailed, or two-tailed? We'll get to that in a minute. So the first thing is the claim. So write down what you think the claim is, and then I will go and pick someone to do this, do the opposite, and then we will figure out H sub O and H sub A, and then left, right, or two-tailed. Let me go find my randomizer of terror. Manage attendance. Yeah, let me just update my attendance. We had someone sneak in. Here we are. All right, very good. All right, I think this is easy enough that we don't need to spend too much time on this. So let's see if we can get the claim. Abby, what do you think the claim is?
Do you want like the sentence or?
Yeah, you could do the sentence.
If the mean salary of nurses is different than 45,000.
Yeah, there it is right there. That's what we're interested in. So that's our claim. Oh, do you want to do it as symbols?
I think I have it right.
Yeah, what do you got?
I have mean is not equal to 45,000.
Beautiful. That's perfect. So yeah, you take that thing, that's the claim. It's usually written right in the body of the text or whatever problem you're working on. So you take that and separate it out and write it as plain math in symbols. Well done. Next, we're going to do the opposite of that. So let's see, can you think of the opposite of this? Blair, what would be the opposite of this mathematical statement? That they're the same? Yeah. So mu is equal to $45,000. Very nice. You're doing great. Next, we need to know which of those. So here's the deal. If you've done this correctly, these two things will be opposites of one another. One of them will be the null hypothesis. One will be the alternative. So let's see if we can sort that out. I'll bet you can. Evan, which of those do you think is the null hypothesis? This one, yes. Why would you say that? You're right. Just the intuition. Okay, good job. Yeah, so it's the one that has equals in it. So when you say this is mu is equal to, this is not equal to. Not equal to is never the null hypothesis. Null hypothesis is equal. So in terms of these symbols, oh, I erased them all, didn't I? Oh well. In terms of the symbols, you want a symbol that has an equal sign in it. This one doesn't count because it's got a slash through it. So the null hypothesis will be, oh no, come back, will be that mu is equal to 45,000. And the alternative hypothesis is that mu is not equal to 45,000. Okay, now we haven't really spent a lot of time on this left, right, two-tailed, but I'll bet you can figure it out. See if you can take a guess. Take a guess as to what you think it is. Is it left-tailed, right-tailed, or two-tailed? Just take a guess. You can keep it in your head. You don't have to write it down if you don't want to. All right, Caden, what's your guess? Two-tailed. Very good. Yeah, not equal to. Not equal to just means here's 45,000. It's either down there or up there. I don't care where it is. It's just not here. Two-tailed. Not equal to is two-tailed. Beautiful. So that's a two-tailed, two-tailed. Now, there's a reason why we're going to be interested in this business when we do our calculations. The calculations for left-tailed, right-tailed, and two-tailed will be different. So knowing what it is going to be important. All right, let's see. How much time we got? We have to have time to do some fun stuff, but we'll do the boring stuff first. So I just screenshotted a bunch of problems that you have from your homework just to show you what Newton is going to show to you so that we can be in the same place. One of the things that is a little bit different from the way I do it and the way Newton does it is with the way that they present their null hypothesis. So here's a good example. Let's read this through. It says a pharmaceutical company claims, so right off the bat you see that word claim, that at least 38% of adults blah, blah, blah. We don't even, I mean, honestly, whenever I do problems like this, if I'm just trying to figure out what the answer is quickly, I stop reading after this. So right there, I guess that's kind of rude, but whatever, because I'm done. I know what I need to do. I have my claim. The claim is that, so here's the claim, is that, and here, this is not a mean, is it? That's a proportion. So now we're going to switch gears and use proportions. So proportion is at least, that is, those words mean greater than or equal to 38%. So that's going to be my claim. This is going to be hard because you're going to have to remember back in algebra class, and I know, like I said, it's been 6 or 7 years since you had symbols like that. You have to remember what these words, what the translations are. At least means at least this or bigger. So this number or bigger. So greater than or equal to. So that's the claim. Now I'll do the opposite of the claim. Opposite is going to be P is less than 38%. So before you, when you get a problem like this, don't go right to your hypotheses. Always start with the claim, opposite of the claim. You know, take a piece of scrap paper and do it. I mean, I can't do math without at least a piece of paper in front of me. Even if I don't use it, I gotta have the paper, I gotta have a pen or a pencil. I don't know if you can do it in your head, but it's really helpful to write down something. So now I've got those. Now I can say, okay, what is the null and alternative hypotheses? Well, you know the drill now. This one right here is the null hypothesis. So I'll just do this. This one is H sub 0. Okay, that shows up good. And this one is H sub A. So let's go pick out of the list here, H sub 0. Wait a minute. Look at this. All of their H sub 0s are just P is equal to 0.38. So this is one of the things Newton does, and some statisticians do it this way. It's totally fine, but I just wanted to point out the difference. I find it useful to do it the way I do it, but then when you go to Newton, just be aware that their null hypothesis will always be equal. So they drop the greater than part, and the reason is that, and this is sort of, it's valid, that null hypothesis means no difference, not bigger than, not less than. So philosophically, I can understand why we would do it this way, but in order to form my hypotheses, I find it much better to do it that way. So when you go to Newton, just be aware that these will all be equals. So the thing you're going to want to look at is the opposite, the alternative hypothesis. It looks like this is the correct one here. Yeah, definitely not here. So this one is the correct one. So I would select this one when I get to Newton, and that'll get the job done. Okay, so I wanted to make sure that that got out of the way. Let's see, there's some other things. Which of the following results in a null and alternative hypotheses? So here again, notice that the null hypothesis looks like this. When I do problems like this on Newton, I look at the alternative and then I rewrite this to be the opposite of the alternative. So that's that. You know, just so that in my mind I can understand what I'm looking for. So I'm looking for a statement that either says that the proportion is less than or equal to 69%, or a statement that says that the proportion is greater than. So let's see, a mechanic wants to show blah, 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 is not 69%. That's not equal to, so it's not going to be that. Okay, blah, blah, blah. More than, that's this. And then contrary to the study, okay, at most. Okay, so that's the one I believe. Let me just double check. At most, no. More than, oh, wait a minute. Uh-oh, which one is which? Those are really similar. Which of the following results in a null and alternative hypothesis? A study found that the percentage is more than. Okay, yeah. Here we go. Less than. Okay, so this isn't it either. So it's going to be one of these. Okay, so there is a nuance that I was trying to avoid, but we got to deal with. So it turns out that hypothesis testing never proves the null hypothesis. You never prove the null hypothesis. Well, you don't prove anything. I hate to even use that word. You never find evidence for the null hypothesis. You're always looking for evidence for the alternative. So to distinguish between these two, both of these would seemingly result in these two null and alternative hypotheses. But the important difference is, in this case, you have the statistical study that found that the percentage is more than 69%. So the conclusions that you draw from statistical studies will always be about the alternative hypothesis. And so since the study has been done, it will always be about the alternative. So there's that one. Maybe that's why I copied and pasted this one. Is because sometimes you're going to have two options. Just be aware, statistical studies always conclude something about the alternative hypothesis. We'll have more on this as we go forward. Wow, I only have 8 minutes. Can we do this? Right-tailed test, I think you can figure this out. Right-tailed means that the alternative hypothesis is bigger than. Alternative hypothesis is bigger than. Those will be right-tailed tests, so that won't be a problem for you. Blah, blah, blah. Oh, no, we don't have this yet. That's not yet, thankfully. Okay, so a few more statistics you can use. Do we really want to do this? I don't know. Did we do the urination study yet? This is if you hold it, you do worse on a test. Okay, the only reason I wanted to put this up here again, so we've already done this, is that if you look at the study closely, there are p-values, which seems appropriate for a study about p, doesn't it? But so p-values in the study. So anyway, the reason for this is because we are going to compute p-values in this class. That's going to be one of the cornerstones of a hypothesis test, is to compute these p-values. Do we need to do this next thing now? I don't know that we do. You know what? I hope we have enough for, yeah, we don't want to do this yet. Yeah, we don't want to do that. We'll save this. You know what I'll do is we will do this. Let's just set up a, here we go, a magic trick. Just a quick magic trick. This won't take too long. So I want you to think of a number, two-digit number. Two-digit number, you can do it. Take your two-digit number. And so, for example, you might be thinking of 48, 97. You might want to write it down somewhere. So think of your two-digit number, write it down, and then add the two digits together. So, for example, if you have 48, you would add 4 plus 8. If you had 97, I would have 9 plus 7. Once you've got your sum of your two digits, you're going to subtract the sum from the original number. So if I had 48, I would take 48, subtract off 12, and I would get whatever I got. So you do the same with your number. Once you have your new number, so whatever number you get here, so this equals something, you want to focus on that number, whatever number this is. So take your original number, subtract off the sum of the two digits, you'll get a new number. Now what I'm going to do is I'm going to show you a grid of symbols. In that grid, you will find your number. And below your number, I think, below your number, you will see a symbol. So you're going to want to, as quickly as possible, find this number, not your original number, your new number. Your new number, find it in the grid and look at the symbol underneath your number. You ready? Okay, here we go. Everyone got your number? Okay, some of you are like, I don't even care. Okay, well, let's see. For those of you who care, oh yeah, find your answer. Okay, ready? Here we go. I'm only going to show it to you for 2 seconds. Find your number. Look at your symbol. You're looking at this symbol, right? Thank you very much. Okay, now, yeah, so here's the deal, is that the hypotheses, this is a good example for a null and alternative hypothesis. The null hypothesis is sometimes called the chance hypothesis, and the chance hypothesis is just that I got lucky and happened to pick the symbol that you were staring at. The alternative hypothesis is that something funny is going on. You know the deal is that if you think that the two versions of the test are different, you think, oh, you made a mistake, and this one is harder than this. That something else is going on, and what that something else is that either Dr. Noonan could read minds, or maybe there's some math involved. Indeed, there is some math involved. I just was careful with my little equation I gave you. So if you want to know how the trick worked, which I know some of you do, I made sure that everybody ended up with a number that was a multiple of 9. That's, you think about it, your number of the math involved, we can talk about later, but notice that all the multiples of 9s have bicycles. And I kind of spread them around so that it wouldn't be obvious. I was hoping it wouldn't be obvious that there were a bunch of bicycles. And most of the other symbols are unique. So all the bicycles are the multiples of 9, and everything else is just whatever. So that's how that works. So anyway, that's just an example of null and alternative hypothesis. We'll get to p-value and do another magic. Did I do a magic trick at the beginning of class? Oh, darn, I wanted to do that one again. Okay, well, I'll pick another one to do for next time for the p-value, because the p-value is a probability. It's the probability that I got lucky. And that we can actually compute with at least a different magic trick. So we'll do another one, and we'll do that. Okay, so hopefully you have enough work. Do make appointments with me so that I can help you with your homework or with your projects. Otherwise, I hope you have a great day and you get